Projections of solids, problem 13.22. A hexagonal pyramid, base 25 mm, side and axis 55 mm long, has one of its slant edges on the ground. A plane containing that edge and the axis is perpendicular to the HP and inclined at 45 degrees to the VP. Draw its projections when the apex is nearer the VP than the base. Assume the pyramid to be resting on the ground on its base with a slant edge parallel to the VP. Draw the top view of the pyramid with a side of the hexagon parallel to XY. The lines AO and DO for the slant edges will also be parallel to XY. Project the front view. Tilt this front view so that A'(O') or D'(O') is in XY. Project the second top view. Draw a new reference line X1Y1 making 45 degrees angle with O1D1, the top view of the axis, and project the final front view. The problem is thus solved by combination of the change of position and change of reference line methods. Sections of cylinders. Section plane inclined to the base. Problem 14.17. A cylinder of 40 mm diameter, 60 mm height and having its axis vertical is cut by a section plane perpendicular to the VP, inclined at 45 degrees to the HP and intersecting the axis 32 mm above the base. Draw its front view, sectional top view, sectional side view and true shape of the section. As the cylinder has no edges, a number of lines representing the generators may be assumed on its curved surface by dividing the base circle into, say, 12 equal parts. Name the points at which these lines are cut by the VT. In the top view, these points lie on the circle and hence the same circle is the top view of the section. The width of the section at any point, say C', will be equal to the length of the chord C1 in the top view. The true shape of the section may be drawn around the center line AG, drawn parallel to VT as shown. It is an ellipse, the major axis of which is equal to the length of the section plane, that is A'G', and the minor axis equal to the diameter of the cylinder, that is D1. Project the sectional side view as shown. The section will be seen as a circle because the section plane makes 45 degrees angle with XY. Sections of cones. Section plane inclined to the base of the cone at an angle greater than the angle of inclination of the generators with the base. Problem 14.26. A cone, base 45 mm diameter and axis 55 mm long, is resting on the HP on its base. It is cut by a section plane perpendicular to both the HP and the VP and 6 mm away from the axis. Draw its front view, top view and sectional side view. The section will be seen as a line perpendicular to XY in both the front view and the top view. The side view will show the true shape of the section. The width of the section at any point, say C', will be equal to C1 obtained by the circle method. Draw the side view of the cone. Project the points on the section in the side view, taking the widths from the top view. For example, through C', draw a horizontal line. Mark on it points C'' and C''1 equidistant from and on both sides of the axis so that C''C''1 equals C1. Draw a curve through the points thus obtained. It will be a hyperbola. Methods of development of surfaces. The following are the principal methods of development of surfaces. 1. Parallel line development. It is employed in case of prisms and cylinders in which stretch out line principle is used. Lines AA and A1 in the figure are called the stretch out lines. 2. Radial line development. It is used for pyramids and cones in which the true length of the slant edge or the generator is used as radius. 3. Triangulation development. This is used to develop transition pieces. This is simply a method of dividing a surface into a number of triangles and transferring them into the development. Approximate method. It is used to develop objects of double curved or warped surfaces as sphere, paraboloid, ellipsoid, hyperboloid and helicoid. As an example, let us develop the surface of a sphere. The surface of a sphere can be approximately developed by dividing it into a number of parts. The division may be made in two different ways. 1. In zones and 2. In lunes. Zone is the portion of the sphere enclosed between two planes perpendicular to the axis. Divide top half of a sphere into 4 zones of A, B, C and D of equal width W in front view. Project these zones on top view. Each zone becomes a cone frustum except the uppermost zone A, which becomes a cone of small altitude. Development of these zones A, B, C and D will give the development of the half sphere. Let us carry out the development of zone C. Divide the zone C into 12 equal parts in top view. Label them from 1 to 12 and 1 dash to 12 dash respectively. Join Q and R and extend this line to intersect at C1 with vertical center line. Similarly, join 7 and 7 dash and extend up to C1. Now, zone C is the frustum of cone C1, Q7. With C1 as center and C1 7 dash as radius, draw an arc A1. Similarly, with C1 as center and C7 as radius, draw an arc A2. Divide the arc A2 into 12 equal parts such that the length of each part is taken from top view. That is, length 7/8 in top view equals length 7/8 in front view. Length 8/9 in top view equals length 8/9 in front view, and so on. Similarly, divide the arc A1 into 12 equal parts such that the length of each part is taken from top view. That is, length 7-8- in top view equals length 7-8- in front view. Length 8-9- in top view equals length 8-9- in front view, and so on. Hence, the portion between two arcs is the development of zone C. Similarly, complete the development of zone A, B and D. Division in loones. Loon is the portion between two planes which contains the axis of the sphere. For development, let us divide sphere into 12 loons as shown in 3D view. Similarly, divide the sphere in front view into 12 loons. Select one loon as shown with shaded portion for development. The shaded semicircle QR is the top view of the loon. Divide the semicircle QR of top view into 8 equal parts and label them from 1 to 7. Project the division points of top view on front view to get 1-, 2-, 3-, 4-, 5-, 6-, 7- points on horizontal center line. With Q' as center and radii equal to Q'1', Q'2', and Q'3', draw arcs AB, CD and EF which will show the width of the loon at points 1 and 7, 2 and 6 and 3 and 5 respectively. Draw a line QR in line of horizontal center line and divide line QR into 8 equal parts by taking length of each part from top view. That is, length Q1 on top view equals length Q1 on line QR. Length 1-2 on top view equals length 1-2 on line QR. Length 2-3 on top view equals length 2-3 on line QR, so on. Length 7R on top view equals length 7R on line QR respectively. Draw perpendiculars from points 1 to 7 on line QR. Draw horizontal lines from A and B in front view to cut perpendicular drawn at point 1 of line QR at points A and B respectively. Similarly, draw horizontal lines from C and D in front view to cut perpendicular drawn at point 2 of line QR at points C and D respectively. Similarly, draw horizontal lines from E and F in front view to cut perpendicular drawn at point 3 of line QR at points E and F respectively. Similarly, draw horizontal lines from G and H in front view to cut perpendicular drawn at point 4 of line QR at points G and H respectively. Similarly, get points on remaining perpendicular lines. Draw smooth curve through points Q, A, C, E, G, I, K, M and R. Similarly, draw smooth curve through points Q, B, D, F, H, J, L, N and R. Thus, the figure obtained will be the approximate development of 12th portion of the surface of the sphere.